In this video, we are going to see the load test on separately excited DC shunt generator. So the aim of this experiment is to conduct the load test on separately excited DC shunt generator and to obtain the load characteristics. So separately excited DC shunt generator, in the sense you have to give separate excitation for field winding. So this is what we are going to do. So what are the apparatus that is required for conducting this experiment? Where first thing is you require an ammeter in the range of 0 to 2 amps, and again you are in need of another one ammeter in the range of 0 to 20 amps, and next you are in need of one voltmeter in the range of 0 to 300 volts, and next you are in need of rheostat in the range of 175 ohm bar 1.5 amps, and you are in need of a loading rheostat which is 5 kilowatt 230 volt, and next thing you are in need of a tachometer and some connecting wires. So these are all the requirements for conducting this load test on separately excited DC shunt generator. So before starting this experiment, what are all the precautions to be done? So first thing is ensure that the motor field rheostat should be kept in minimum resistance position. So also ensure that the generator field rheostat should be kept in maximum resistance position. So before starting this experiment, ensure both the condition. So next thing is I'll show you the circuit diagram. So this is what the circuit diagram for conducting the load test on separately excited DC shunt generator. So this is what the motor generator set that is being coupled. So here you are having a 3-point starter. So LFA, that is line, field and armature. So here you are having a field rheostat at the motor side. Also in this side you are having a rheostat. So this is what the field rheostat of generator side. So here we are giving separate excitation to the field. So that is given by means of using one more 220 volt DC supply, and this is what the ammeter which is being connected, and this is what the supply that is being connected, voltmeter which is connected across the load. So now we are going to conduct the experiment. So let me explain the procedure for conducting this experiment. So first thing is the connections were made as per the circuit diagram. So supply is given by closing the DPST switch. So after ensuring all these two conditions, what you have to do is you have to close the DPST switch. So then use the DC 3-point starter to start the motor. After that, what you have to do is the field rheostat of the motor is adjusted to run the motor at rated speed. So first thing you have to, once you have started the machine, the thing you have to do is you have to adjust the field rheostat of the motor. So this motor is being considered as the input to the generator. So this motor will provide mechanical energy which is given as input to the generator that is being coupled to the motor. So after this, the generator field rheostat is adjusted for rated voltage. So after that, the DPST switch in the generator side is closed. So now increase the resistive load in steps of 1 amps and note down the load current and terminal voltage. So repeat the value until the rated voltage is time. So then the resistive load is gradually decreased and the DPST switch on the generator side is open. So then the supply is switched off. So the generator EG is calculated using the formulas which is being mentioned above. So you can use this formula for calculating this generated voltage. So now we'll see practically how this experiment is being done.
So connections were given as per the circuit diagram. So before giving the input supply, ensure the motor rheostat is in minimum position as well as the generator side rheostat should be in maximum position. So now turn on the supply. Then gradually start down the starter. note down the speed of the motor. So it is it is 1476. Vary the motor side rheostat slightly in order to obtain the rated speed of the motor. Now check it with the tachometer. Now the speed is 1540. Adjust the rheostat. Now you got the speed which is related to 1500. So the field rheostat of the motor is set. Now vary the generator side rheostat in order to get the maximum generated voltage. So now you can see the panel. The field current is getting varied. Along with that, the generating voltage is also getting varied. So for different values of field current, note down the generated voltage. So vary the rheostat, that is generated side rheostat, until the rated generated voltage is obtained. So now you can observe the voltage is being generated in the generator. So the maximum generated voltage is 200 volts in this case of set. So now you can observe the field current, it is 0.5 amps. So for 0.5 amps you got the maximum generated voltage. So note down these values in the tabular column. So that is for different values of field current until the rated generated voltage is obtained. Take down the readings. So note these readings in the tabular column. So here the first value that is obtained is 0.1 amps. For that the generated voltage is 100 volts. Gradually vary the values. So until the maximum generated voltage, which is 200 volt, is obtained. At that time the field current value, which is 0.5 amps. Now turn on the load. So here we have turned on the load. First I have applied a 250 volts load. So now you can see the voltmeter as well as ammeter readings. For different values of load current or by applying different loads, note down the voltmeter as well as ammeter readings. So next, increase the load. So now I have turned on one more load, which is 250 watts. So now totally the load which is being applied is 500 watts. So for this the load current, it is 1 amps. Similarly, apply different loads. Now I have turned on one more 500 watts load. Now the overall load is 1000 watts. For this 1000 watts, the load current is getting varied, which is 4 amps now. So similarly, for different loads until the rated current, you can vary it and note down the voltmeter and ammeter readings. So this is the tabulation in which you have to note down the readings. So you are having the field current. So you can see the panel. So the field current, it is in 0.5. For this the load current, it is 3 amps for 1000 watts load, and the voltage, generated voltage, it is 200 volts. Similarly, you can apply different loads and take different readings, and finally you have to calculate the IA value by means of adding load current plus field current, and the generated value will be the voltmeter reading plus IA into RA. So with this you can in the tabular column and then you have to plot a graph with the generated voltage as well as to the field current and load current. So you'll be getting two graphs. So after plotting the values, load characteristics were obtained. So now the experiment is almost done. So before turning off, turn off the load. Then make the generator side rheostat to the maximum position, as well as the field rheostat of the motor side to the minimum position. And now turn off the supply. So this is the load characteristics of DC shunt generator. So with this the experiment is done. Thank you.